What's going on, everybody? Mr. Diamond. We are now going to talk about balancing redox reactions. So these are going to be pretty straightforward. We're still building in difficulty. I would say that just the knowing oxidation numbers is pretty easy. Then it gets a little bit harder when you start talking about half reactions, a little bit harder when you talk about balancing. The last piece we're going to talk about is where we'll get that big spike in difficulty, and it'll get quite a bit more difficult. But in this case, we've got a pretty easy example here. We have Ag and we have Cu that are reacting with each other. So on the left side, we have Cu that has no charge, so that's 0. On the right side, we have Ag that has no charge, that's 0. On the left side, we have Ag that's a +1. On Cu, we have it that is a +2 for the right side. So this one was really easy to get our oxidation numbers, and now we can look at what we've got. Well, our half reaction for Ag must be Ag plus turns into Ag, but this plus has to have gotten canceled out somehow, so we'll need to put an electron there, because again, our goal is to make sure that our charges on each side are balanced. One positive and one negative would cancel and make it neutral. Then for our second reaction, we'll have copper. On the left side, we'll have copper, and that copper is going to turn into copper with a 2+, and in this case, it's going to need 2 electrons. Now, this is where I kind of, in the notes, I was able to explain it not so great, but being able to actually have the paper in front of us will make this a little bit easier. So what's happening here is that at the same time in this reaction, this copper that is right here is giving up 2 of its electrons, and those 2 electrons are going to the silver. Now the silver only needs 1 to react to form a silver that is a neutral compound, so it's going to take in 1 of those electrons. But that would mean we'd have an electron left over. And if you mix copper and a silver ion together, you do not generate infinite electrons. Electrons don't just pop into existence. So we need to make sure that these are actually balanced. And so to do that, we have to make our electrons for each equation equal to one another using the lowest possible numbers that we can. In this case, we do that by multiplying each of them by 2. Now, before we do that, though, we've skipped over this piece. A lot of people have skipped over this on last year whenever they were doing this worksheet, so please make sure that you remember to circle whether or not it is something that is oxidized or something that is reduced. Oxidation is loss of electrons, so in this case it is combining in electrons, or it's adding an electron, so we would not call that oxidation, we would call that reduction. Reduction is a gain in electrons, and that must mean the other one is oxidation. So now for our balanced equation, we literally just combine together. There would be normally 2 electrons plus 2 Ags with a positive plus a Cu gives us a Cu with a 2+, 2 Ags with no charge, and then 2 electrons. But notice, just like in math, we have 2 electrons on each side. Those will actually go away, and we would not need to write them because they're on both sides. It's just like having an equation where it's like 5x equals 5x. Well, yeah, there's an x. Well, I guess that's a bad example because there's x's on both sides. This is why I'm not a math teacher. But I guess it would be like having a 5x equals 5. That's a little bit better. We can cancel that out. We can get rid of those 5's on both sides and cancel that. Or it's like having x plus 3 equals 5x plus 5 plus 3. Like having this plus 3 on both sides just can go away. Again, these are bad examples. This is why I'm not a math teacher. You can just ignore that. Point of it is, if you have something on both sides of the equation, you can cancel it out. And we have something on both sides of the equation, so we're going to cancel it out. All right, that is how we balance our redox reactions. Again, easing into the more difficult stuff, this last section is going to be the one that'll be more difficult than either of these and takes usually the most mental effort. So if you have any questions, please send me an email. Otherwise, this is Mr. Diamond signing off. Have a good rest of your day, everybody.